Welcome to the control systems. This is part 5 of lecture 7, transient and steady state response analysis. So in this section we'll discuss how to get the rise time, peak times, maximum overshoot, settling time. Okay, so first, let's compute the rise time. So refer to the equation 4. We obtain the rise time by letting CTR equal 1. So if you recall, the definition of the rise time, okay, the time required for the response to rise from 10 to 90 or 0 to 100. So that means CT is more or less equal to 1. So if you let this CTR equal 1 and then equate with the equation 14, and since this term is not 0, and we obtain the following equation, we just do the math. And we know that this equal to this, and this one equal to this one. So you finally obtain this tan omega dt or equal minus omega d over sigma. And thus the right time t is this one, 1 over omega d and arctan of omega d over minus sigma, which is equivalent to this if you look at this. Okay, so you define this angle is delta, and then this angle is pi minus delta. Okay, so clearly for small value of tr, omega d angle delta must be large. And for the peak time, referring to the same peak time, you need to refer to equation 14 again, and we may obtain the peak time by differentiating CT, okay, with respect to the time and letting the derivative equal to 0. If you do the derivative and equate it to 0, okay, so you will obtain this one, sine omega dTp equal to 0. Okay, and omega d Tp equals 0 pi to pi. But the peak time is the time at the first peak. So since the first time corresponds to the first peak overshoot, Tp is just equal to pi this over omega d. That is the peak time. And for the maximum overshoot, so MP occur at the peak time or at t equal Tp equal pi over omega d. And you can substitute. So if you first, we need to assume that the final value of the output is unity. Okay, so simply it is for simplicity, and then maximum overshoot equal C at Tp minus 1. Okay. This is the result. So if the final value C infinity of the output is not unity, then we need to use these following equations. And for the settling time Ts for underdamped second order system, the transient response is obtained from equation 14 as this one. Okay. So for convenience, in comparing with the response of the system, we commonly define settling time equal 4 times t. Okay, usually 2%, or sometimes 3% if you want. Thank you for watching this video.